So welcome, thanks for coming. Check the widgets working here. Details about me. Self-employed software consultant, trainer, coach, whatever the latest buzzword is. And I know, hands up those who know what CyberDojo is. Okay, about half, thanks. I'm planning to do this in two halves, sort of roughly 45 minutes each. First half, I'm just going to tell the story of how CyberDojo came about, and I don't think we see any code in those slides at all. And then we look at some code. And there are no slides for that at all. We're just going to actually do code. And I'm going to, for once, I think that the network is sufficiently OK that I can trust it at an ACCU conference. So I'm going to summon the daemon gods and actually install the server as part of the demo. Fingers crossed. OK? So that's the plan. So when did it all start? It was late 2009. I've tried to find the exact date because it was actually a meetup in Oslo, but I can't find it on the web anymore. But it was definitely late 2009. And I was doing some work in Oslo, and one evening there was a coding dojo in this pub called the Scotsman. Anyone been to that pub in Oslo? Great pub. But mostly I like it as a great pub because whenever I go there with lots of people I like, and it's the company that makes a difference, right? Anyway, that's where it was being held, in the upstairs floor. And Uncle Bob, Robert Martin, one of the Agile signatory manifestos, was there. Not for that. I think he was doing something somewhere else at some company. And as is often the case, local techies found out about it, asked him if he would do a talk in the evening, and he said, yeah. And at the time, I suppose he was quite into coding dojos, or maybe they asked him, I don't know. And he did a coding dojo. For those of you who aren't familiar with the term, dojo literally is a Japanese word that means the place where martial artists practice their martial art. It's a building, a physical place. And that's the analogy that I've used, as you'll see. There was about 30 of us there, and we were split into either 5 or 6 groups. I can't remember exactly how many. I think it was 6 groups of 5. And the exercise that Uncle Bob picked was battleships, which I'm sure you're familiar with. It's not important if you're not. And he also picked the language. And for the life of me, I can't remember what language it was. And he also picked the test framework, and I can't remember what that was either. It doesn't really matter, which is why I don't remember it. And off we went for a good hour and a half. After an hour and a half, we stopped, and the idea was that each of the 6 groups would take a little short turn to present the work that they'd done by hooking one of their laptops up to a projector, presumably the one that they'd been working on. They'd do a quick demo and show something. The next one would come up and do it. The next one would come up. The next one would come up. And that was the plan. So what happened? Anyone guess? When they attempted to show their work. No, it wasn't that bad. No, they agreed what each group, as they brought their laptops, 5 people came up, they were the first group. The idea was they'd connect their laptop to the projector. Projector setup. Yeah? It's not as bad nowadays, although we still see it. Remember Cope? Did anyone go to Cope's talk on Wednesday night? 15 minutes trying to get his laptop set up. He was plugging in a cable like this, fiddling around, all people doing all kinds of things for at least 15 minutes, and then someone came up, looked at the cable, followed the end of the cable went nowhere. So an enormous amount of time was wasted just getting each of them connected their damn laptops up just to show something. And when they did connect their laptops up, 4 of the groups had something to show, really, which was fine, remembering that they hadn't chosen the language or test framework that had been picked for them. But two of the groups basically didn't have very much to show at all. Why was that? They'd been attempting to install the compiler and the test framework that Uncle Bob had chosen, and they didn't have it on any of their machines, and they had problems. They just had all kinds of problems. Pretty much it was not a good end to the coding dojo. And the third thing I remember about that evening in particular was eventually, after all of the groups had shown what they'd done, Uncle Bob pronounced one of the groups the winners. Oh, I didn't really get that at all, but that's what happened. So I was thinking about that in my hotel room that night, and I thought, how could we have avoided particularly this problem? And as it turned out, solve the same problem at the same time of the damn projectors. So I was thinking, what's the minimum amount you would need to install if you'd been a participant at that coding dojo? And what would be the minimum amount needed to install? The minimum amount is 0, okay? Because you don't have to install anything, assuming you have a browser, right? You could just use the browser. And the more I thought about that idea, the more I really liked that idea. Because if the code is on the browser for each of the participants, then when they have to somehow submit their code in the browser to the server can take a snapshot of that code. All the code at all times is available on the server for all of the groups. So they can just go ahead and code for an hour and a half or a bit longer, and all the time, a different laptop, Uncle Bob's laptop, let's say, could have been connected up to the projector. Maybe there'd have been problems, but that could have been sorted while they were doing their work. And then he could have just literally gone 1, 2, 3, 4, 5, 6, and seen the code and projected the code that they'd done. All the problems would have been solved. So that was the genesis of the idea that evening in Oslo in 2009. So the answer was to put the server on the cloud, put the work on the cloud, put all the compilers on the cloud to solve that problem. But mostly what I liked was the idea that there'd be a projector, just one projector connected at the front all the time, and at the end, you'd have the ability to look at all the code. Now, there's a couple of other things that fell into place fairly quickly. One of them was integrating the ability to do tests. I very quickly realized that I wanted to have this in a way that was, I was going to say testing was non-optional, but I can't say that in truth, because I've watched people do coding in CyberDojo, and the ingenuity that people show not to write tests is quite extraordinary. So as you'll see, because I'll do a quick demo, it's pretty hard not to write tests because of the way it's been built. Okay. So I rolled up my sleeves. I decided, at certain times in your life, you think there's something that's an idea that's worth committing your time to. And I did so. That was 2009. And this is slightly out of date. We're almost up to 8,000 commits now. Not all of which are me, but most of which are me. We have something that seems to scratch an itch. Yeah. It's on GitHub. It's open sourced. It's based on a Ruby on Rails server, but there isn't really that much Rails and that much Ruby. That's just a bit of glue code mostly to get the files that are sent from the browser received on the server, and then the server has to essentially coordinate three things. There's putting the files on the file system, letting Git do the heavy lifting, because each animal has their own individual Git repository, so that when we do a review, we can see each of the work that's being performed by each of the groups. And the other thing now that does a lot of the heavy lifting is Docker. Because if you think about what's happening here, people are writing arbitrary code in a browser, and they're submitting it, and it's being run on my server. And potentially there are issues there, potentially quite serious issues, because someone could hijack the server, for example, and start to use it as a resource for doing Bitcoin mining or something like that, okay? Or worse, yeah? So there's a bit related to that idea, which we'll see shortly as well. So a quick demo. So there's not only the site itself, which is here, that's the main public server, there's also a blog site that's associated with it. And if you want to run your own server, as I said, I'm going to summon the demon gods, you have to install Docker. As I said, Docker pretty much is doing most of the heavy lifting. So I need to get onto my remote machine, which is here. That's the one. Okay. So I've got that. And this will take a short while. While this is going, I'll just say I've got two MacBooks, MacBook Pros, an old one and a new one. The new one has died. The trackpad has just completely died. It worked for a while with a USB mouse attached. Even that doesn't work now, okay? So I'm on my old laptop. So I'm summoning double demon gods here. There's some stuff I think I was planning to do. I'm pretty sure it isn't going to work if I do it on my local machine. So I'll try and do everything on the remote machine instead. Okay. So it's installing Docker. It's also installing part of the Docker family, which is called Docker Machine. Again, you don't have to know anything about this if you don't want to. If you just want to run the server as a tool, that's fine. And the third piece of the puzzle it's installing is something called Docker Compose. Yeah. We might see some of the Docker Compose stuff shortly. So you've installed Docker, which is doing the infrastructure heavy lifting, and then you have to get CyberDojo up and running. And it used to be the case that to get this working, you had to follow a series of really quite tortuous incantations, basically involving pulling the Git repository source code, doing a few other things, crossing your fingers, hoping the wind was in the right direction, and often things went wrong, as I'm sure some people can testify. So again, fingers crossed now. We've got a better way of doing things. We've got just a tiny little shell script, and it does all the work underneath the hood. And we just need to bring the server up. So there's some stuff going on here quite quickly. It's scrolling by. Again, this is Docker under the hood. The main server is now inside a Docker container itself. Yeah, so it's trying to bring up the server, and it says, well, I can't find that image. And the way Docker works is it just tries to pull that image from a repository using the Git model. Yeah, you're not pulling code. You're pulling a container that's actually runnable. Yeah, and the naming works. The name to the left of the slash is the repository. So I've got a repository called CyberDojo Foundation. And the name after the slash before the colon is the name of the image. And then the tag after the colon, you can do whatever you like with that, but I use it for the version number, which is pretty much what people do. And it goes away and does all its stuff. And there's some extra stuff I'm not going to particularly talk about right now. And then it starts to pull a few of the containers, because the way CyberDojo works is with a sort of plug-in architecture. If you wanted to run your own CyberDojo with your own particular language, for example, my friend Byron here is working on Swift, right? He's working on making an image for Swift. Then once he's done that, we'll literally just have to be able to put that image into the CyberDojo Foundation repository, hook it up into the web server, and it'll just be available. Yeah, there's nothing I have to do in terms of modifying my code. It'll just be available. So what's happening now is it's pulling a number of images, which aren't Swift, because Swift isn't there yet, but there's a few coming through. I don't know if you saw it, but the first one there, GCC assert, that went very fast. It pulled that one very fast, because the size of that image is only about 200 megabytes. And the reason for that is because I've explicitly worked on that one to get that one based on the Alpine Linux distribution, which is built to be very small, okay? Hopefully some of the others will eventually be moved forwards towards also being based on the Alpine image, so that they too will be very small, because there's a lot of bloat, frankly, in a lot of these images, which isn't a problem, except if you're pulling them, which people are now doing, okay? So GPP assert is the G++ version, using assert as a test framework. C# obviously is the mono C#. using NUnit as a test framework. Java's another big one because that has jar files associated with it for JUnit. And there's a couple more to go. They get a little bit smaller at the bottom. There's Python going through. We'll just wait for those to go through. Any questions while we're waiting for those to go through? No? I'll have some of my emergency peanuts. I'm starving.
I did have a question. So all you've done is move the security problem around to what's in the container. So how do you secure the contents? That what is in the container. So it's access controls and stuff like that. Is where you move the problem.
Docker takes care of that because it's effectively a virtual machine technology. But it doesn't actually spin up a virtual machine each time you want to submit your code and tests. That would be too slow. But it's like that, and you get the same security in a container, and it's fast enough to make it viable. Okay? But there are other issues as well, which we'll hopefully talk about. Okay? Okay, images for just the few selection of languages that we've got, that we've picked. There's only 5 or 6. I just fairly arbitrarily selected a few just to get things moving along. It's got an Nginx front end, just to do the caching. Excuse me. And then it's using Docker Compose to bring up the 2 images, 2 containers, I should say, based on the Nginx image and the web image, which is the one I've built, for the actual server, which holds the source code inside it, as I described. So having done that, it should be there. That should be all we need to do. If we go to here and bring up the server, it doesn't work. I haven't opened the port. Try again. Right. So then well, let's just go back a second. Anything I want to say there? No, we'll wait and say that later. So that's the home page on our server, just the same as the home page on the main server. Notice the URL changing in the tab here. That's the main server, and you've got your own now. And for some people, this is an issue, because on the main server, obviously, in theory at least, everything that you submit in the browser and then hit the test button gets sent to the server, and it's saved on the server. And is Neil here? Excellent, there you are, right there. That would be a problem in some banks, for example, because there are firewall issues. So you'd have to run this inside the firewall. Okay. So what happens now is you hit the create practice session, and we can see the languages just for the few 6 that I selected as the starting ones. If you wanted to remove one of these languages, plus its test framework, and add another one, that's easy to do. You just go back here and you invoke that shell script again without the up, and it gives you sort of the minimal syntax you need. So you can remove one of the images, which you can find the name of by just asking for it with the catalog. And then you can pull another one, which again you can see by just asking for it with the catalog. So if I show you that there, then these are all of the language test frameworks. Yeah, the language and test framework. And this is the image name you'd need to know if you were going to add or remove one. Okay, so let's actually do one. So we've got Java and JUnit. Let's pick another Java one. Let's do Java and JMock. So we need that one. Yeah. So we need to pull that one. And then you see exactly the same as what we saw a moment ago, pulling the image for that particular combination, and it's there. Excuse me. Excuse me. Oh. But if we now try and see that in the browser, we won't see it because the browser started before we did that. So we have to bring the server down. And then bring it back up. I should add a restart for that, but again, I just haven't done it yet. I've been fishing a lot lately. And now we've got 2 test frameworks available when you pick Java, okay? You can only, again, it's totally hardwired. that you can't just pick a language, it's always a language plus a test framework, okay? So now you've seen that, we can then make the selection. You then have the option of choosing a pre-canned exercise instructions file, and the classic starter one is always FizzBuzz, and you get the ID. And as long as you know the ID, you can participate wherever you are in the world. Yeah, it doesn't have to be physically in the same room. So at this point, of course, if we were imagining Uncle Bob had been using this tool and we'd have been solving all the problems, Uncle Bob would have done exactly what you just saw me do, choose the language, choose the test framework, there's an ID being created, and each of the laptops that were participating would simply click that button, and then they'd put that number into the text field, and that would enable the buttons, and they'd be able to go, they'd hit start. They're then randomly assigned an avatar, which gives identity to the laptop. It's a very deliberate design decision that something you didn't see here was username, login, password shit, right? I can't stand that stuff, so I was trying to model my value system inside CyberDojo. And again, there is a deeper design behind that, which I'll talk about shortly. So I've been randomly assigned a B, and now we get the environment, which I sort of half-jokingly say is the world's simplest non-development environment. And there is a definite truth behind that, because as it said on the front page, yeah, this is the place to practice programming. When you're developing something in a development environment, you've got all kinds of tools that help you go faster. And that's exactly what you want, because your aim is to finish something and ship it, okay? When you're practicing something, you aren't aiming to finish it. You don't really want things necessarily to help you go faster, because a big part of practice is slowing down, yeah? I'm a really big fan of practice, and in particular, deliberate practice, as I know some of you know. I was chatting to, is Mike here? I guess Mike's probably in the C++ quiz knowing Mike. I was chatting to Mike Long as we were going to one of the restaurants, I think it was last night, was it? No, it was the night before. And he said something which I thought was great. He talked about a book he'd read, I forget the name of the book, I'll have to ask him if you're interested, where it talks about the idea that when there's extra pressure, you know, you can pull something out the bag, a bit like Captain Kirk always used to do. Remember those, right? And in the particular example he said was there's actually a phrase in American baseball for a batter called a clutch hitter. Anyone come across that phrase? I'd never come across it, okay, but maybe we have some friends from across the pond and they've come across it, yeah? And apparently a clutch hitter in baseball culture is someone who's known to be good when the pressure's on, and they're the last batter up in the last innings, and if they hit a home run, their team's going to win, and if they don't, they're not, okay? Well, one of the good things about baseball is there's huge amounts of statistics of the way that people actually performed in precise scenarios of when they were at bat in the certain innings and what the score was at the time. So this guy gathered all this bunch of statistics together to find out whether these people who had this reputation of being a good clutch hitter were actually good clutch hitters. And what did he find? Anyone guess? They weren't. They were completely average. But in terms of psychology, there's a known bias where we remember when something is literally a hit, but we don't remember so well when something is a miss, okay? And it creates a bias. And the other thing he said, there was two things he said. The other thing he said was this idea of practice, again, is something that's very strong in lots of the military. I think he said it was the Navy SEALs. I could be wrong. But in the Navy SEALs, he said, they understand and they recognize that when the pressure's on, which it might well be, if you're in a Navy SEAL in certain situations, you don't rise to the occasion. That's the actual phrase they have. They say, in those situations, you do not rise to the occasion. What happens is you fall back to your level of training. And I thought that's absolutely right. Yeah? So I'm a big fan of practice. And this is part of why it's been built, and it's part of the culture of what a dojo is. A dojo is literally a place where martial artists practice their martial art. So it's not a development environment. It's a practice environment. So there's no color syntax highlighting. Yeah? There's no anything, basically. Yeah? There's no save. There's no compile. The only thing you can pretty much do is hit the test button. And when you do that, the files that we see listed on the left here get sent to the server. They get run on the server. The output's grabbed from the server. And the output's then pattern matched, just using a very simple regex, based on whichever language you're using. And we get back the classic red-green. So in this case, we got a red, and the output says we were expecting 42, but we got 54. And if we look at the test, we can see that we're expecting 42. But in Hitchhiker's Guide culture, which 42 is the answer to life, the universe, and everything, which is required knowledge for all software engineers, yeah. Then the question in the book was what's 6 times 9, which Arthur drew out of the Scrabble bag, if you remember, okay? And that's obviously not 42, it's 54. So we changed, except in base 13. 6 times 9 is actually 42 in base 13, but apparently Douglas Adams didn't know that. So we changed it to 6 times 7, same thing, send the code to the server, it gets saved and git committed in a repository associated with the B for this particular ID, which Uncle Bob would have set up, okay? And pretty much that's it, except for a couple of slight extra things. Given that I'm using the red-green traffic light system here, which is standard coloring for testing, okay? My friend Kevlin, when I started this quite early on, said, well, I can't tell the difference between these. I just had a red blob and a green blob. He's red colorblind, which is the most, I believe, the most common form of colorblindness. He said, I can't tell the difference. So I put the little blobs in at the relevant positional places based on the traffic light system. And when I did that, I realized, of course, there was a gap. We got red and we got green, but we haven't got amber. And I came up with an idea for amber, in that if you just make a complete typo, yeah, and you try and do that one, that's a kind of a different kind of red, yeah? And that's actually an amber. In CyberDojo, that counts as an amber. That's proved tremendously useful, okay? For various reasons we might talk about if you're interested later. Excuse me. Now, very quickly, again, just to show you, Uncle Bob, meanwhile, on his laptop connected to the projector, would have been just showing the dashboard, which shows the line of each animal and their traffic light as it grows, bit by bit by bit. Okay, so I should be helpful if I could show you a nice one. Let me just find a nice one for a minute. When I did the pre-conference on Tuesday, that was one of the dashboards for 1, 2, 3, 4, 5, 6, 7, 8 animals, which means there were 16 people because there's a pair per laptop, okay? So I'll just very briefly talk you through it. Each column is a minute, yeah? The row is the animal. The number here is the number of traffic lights that, what's that, a buffalo has submitted. The color of the number is their current color, and the pie chart is simply a pie chart of the proportion, okay? Mark, you got a question?
Yeah, I think is there a minute where somebody actually ran the test, so the whole group doesn't run the test, so the dashboard updates.
What was the question again?
It's a minute in which at least one pair presses the test button. So if the whole group is stuck and doesn't press test for a couple of minutes, the dashboard doesn't always update.
Yes and no. If 1 minute passes where no one submitted anything, you get a tremendously thin column with 1 dot. If 5 minutes pass where no animal submits any tests, those collapse, okay, into a dot, dot, dot. Yeah, we should have, what's his name? Thomas, we should have Thomas in here doing another dot, 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 right, okay? Yeah? There are reasons for that. Again, I'm not going into it too much, okay? But pretty much you're right, yes, okay? You made me think about that now. No, I have to leave that and carry on. And as I said, the main reason I built this was because every time an animal hits the test button, it gets submitted to the server, and there's a git commit and a git tag that happens at that point, precisely so that we can do a diff. So the way it works is when you're doing the review, you can look at this, and there's some tremendously useful things you can get from just from this, but you can do more than that. You can click on a traffic light and actually get the diff of the cheetah, and this was the diff between submission 8 and submission 9. We can see at the top here, this is the underbar on the red submission 9. So they were moving from green to red, And what did they do? They only edited this one file, and they added 6 lines, which were these 6 lines, so they're obviously adding another test. Okay, the output changed because output changes, right? We move forward again. What was the next thing they did? They got straight to green. This is pretty impressive sequence here. Red, greens, some green refactoring going on, hardly any ambers. There seems to be a lot of good stuff happening here, okay? But as I said, one of the main reasons I built this was precisely for what we're seeing here, the power of the review that you can do. And again, I want to make it clear what's happening here in terms of the value system. If I'm doing, or Uncle Bob was doing a review now, he wouldn't be saying, Roger, what the hell were you thinking here? Right? Okay? He literally doesn't know who this code is. All he knows is that it was the cheater. Somewhere in the audience, there's some developers who know they were the cheater, okay? And as Uncle Bob is hypothesizing about what the heck's going on, because the code isn't understandable, sometimes it is, sometimes it isn't, how much of the intention is revealed, Uncle Bob would have to literally try and verbalize what he's thinking as he sees the code for the first time, yeah? He could say, I think they were thinking this. The cheaters could themselves decide to reveal who they were and say, no, 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 what we were thinking was this. But it's crucial that they get the chance to reveal and the choice of whether they reveal who they are, okay? And again, there's some interesting patterns that happen when you have a group, depending on whether they know each other or not, in terms of how quickly they reveal who they are and things like that, okay? Yeah. So that was the demo. And on the front page, I don't know if you saw it, okay, somewhere at the bottom, there is this, which I've blown up. So this is the licensing model. It's free for non-commercial use. Commercial use requires a license. If you need to license, you simply make a donation. I don't want to have any admin building this tool. I built this for my benefit. I was scratching my own itch. It's just a kind of fortuitous accident that it seems to be, a little bit popular. So I'm not intending to make money from this. So I try and reduce the bureaucracy behind it to as close to zero as I can make it. It's just a donation scheme on a system. And if you do make a donation, all of the money goes to buying Raspberry Pis for kids. And this is done under a proper charity set up by Seb Rose. That's why it's Scottish. He's actually set up a couple of charities before. He knows how to do it really quickly, so he did it for me. This is apparently the numbering system they have in Scotland for charities, so that's the magic number, okay? And if you click that, you can get some blurb about the foundation itself, which is a proper charity. The hosting for the server is paid by Google. Kelsey Hightower saw this when I was doing something in Oslo and gave me loads of credits. Google have given me loads of credits for the hosting, which is very nice of them. So here's an example of Bray is a little town just south of Dublin, so it's about here. And they run a Coder Dojo, not a CyberDojo, a Coder Dojo every week. And here's all the kids in the Coder Dojo. Isn't it fantastic, all the kids, this movement that started based around the Raspberry Pis largely. And Liam, my friend who asked for some pies that they're using inside this, I think there's one there, probably. But that's where all the money goes, to buying Raspberry Pis for kids, okay? So we're getting to the end of the slide bit. Just want to say a quick few thank yous, because it's not me that does all the work. Byron does a lot of work for the images, for the languages, so thank you, Byron. Nadia Sivas is an artist who lives in Ukraine, and she created the images of the 64 animals. Originally, there were only 8 animals, I think it was. And that proved a problem, because some people wanted to do a CyberDojo with lots of people, and there just wasn't physically enough animals, okay? So my friend Dimitro, I should say, who is usually at this conference, but sadly not here this year, he actually put some money forwards to pay Nadia to make the images. Seb, as I said, did the charity stuff. Olve was very instrumental in some of the design behind it. And Mike Long is a real expert in Docker, and he helps me a lot with the Docker. We were doing a little session last night just upstairs in the terrace bar, and we came up with a really nice plan of how we're going to move it forward to the next particular thing we want to do. Okay, so I've touched a little bit on the value system. The fact that it's not a development environment, it's a practice environment is very key. So I thought I'd just give you a quick summary of that. Integrated development environment on the right. This, for me, is kind of the value system, which is right. That's what you want. That's what you want in a development environment, okay? It's individual-based. Yeah, it's kind of accepted each developer has their own machine and they have their own integrated development environment, and any collaboration happens in terms of merges with other code that other developers have built on their own machine with their development environment, okay? As I said, it's focused on finishing. Maybe you're doing test-driven development. The idea is trying to work faster. There's time pressure with deadlines. We certainly don't have the sense of repeating work, which is a very strong aspect of practice, okay? And basically the idea is to make money. And kind of the opposite here in CyberDojo is team-based. So again, when you saw the dashboard, for example, it's very, very deliberate that that's a dashboard showing everyone at the same time. Yeah? Learning-focused. I added the question mark here because, like I said, people are tremendously ingenious about not doing the tests. But it's certainly harder to not do test-driven development in CyberDojo. We work slower. A big part of practice is working slower. There's no time pressure. Maybe you finish, maybe you don't. That's fine. We repeat. And we don't aim to make money, we aim to have fun, because that's a good way of maximizing learning. So when people ask me for new features, I pretty much just give them this reply. That's now in the FAQ. I don't care what you're asking for. There's Thomas again. Some people don't get it. And that's fine, because it's unusual. If I do a CyberDojo with a group I've never met before, I talk about this value system. We do a CyberDojo, the first run, and almost invariably, the first time they do an exercise in CyberDojo, they're still just instinctively using the habits they've got when they used an integrated development environment. They're going fast. They're not taking the opportunity to slow down and relax. Yeah? Second or third time, typically with a new group, you can palpably sense the difference in the room as there's a sort of a relaxation, and they realize we're not shipping a damn thing here. Okay? But it does take time. It's a different way of thinking. It's team-based, not individual, as I said. So here's another dashboard. Noticeable in this one that there's quite a few more ambers. Okay? Maybe there's a bit less red before the green. That's potentially noticeable as well. Over time, you rapidly pick up the patterns from these kind of things. Okay? I'll just mention one other thing about this as well. I was doing some work in Galway last year, and I used CyberDojo. And at the end of the course, one of the participants came up to me and said, "John, that was a really great course, thanks a lot. What I love about CyberDojo is there's nowhere to hide." That was the phrase he used, there's nowhere to hide. Yeah? Because when we click on a traffic light here and we see the code, you know, I'm kind of acting as a mirror, which is a known sort of way of working in psychology, for example. I'm not necessarily pushing any learning to them. I'm just showing them what they've done. Yeah? And they learn a lot from just the code that's across all of the animals across the whole group. Okay? It's their code. I think there's one more. Yeah, learning focused rather than finish focused. And a big part of that is the review that we do step by step by step. Yeah, to really try and get a handle on what are people actually doing step by step by step, so that they can really try to do things more consciously, more deliberately, yeah, and engage their brains in this difficult activity called software development. Okay, a few slides about how did it work. What's this? Camera. What kind of camera? A fake one. If you look closely, it's wooden. Yeah? Apparently some people have this kind of stuff. You can imagine it kind of might make sense sometimes if you want to dissuade a burglar from coming into your house, and at dark it kind of looks like a camera. Now the reason that's up there is because the very, very first early iterations of CyberDojo didn't use Docker. Yeah? I'm quite aggressive about trying to do the simplest possible thing that can work, because I'm doing all of this in my spare time. And I thought about what's the simplest possible security I can have for running code which is arbitrarily submitted from the browser. And I came to the conclusion, initially, it was nothing. No security at all. Instead, what I did was frequent backups. Yeah? And that worked for a remarkably long time until a guy from France brought down the server because in the code that he'd submitted from the browser, he actually put cd / and rm - rf star. He was just playing around. He figured there's got to be security here, brought the whole server down. But he was really nice about it. He emailed me, he said, John, I'm so sorry. I just assumed there was security. I brought the whole server down, right? And that was the point where I thought, maybe I should put some security in, right? So I looked around, and at that point, there was Docker, 0.3. At that point, Docker was at 0.3. It was just a fledgling bit of technology that was starting to get a foothold. So I introduced the architecture for actually putting the one image per language test framework combination. And when you submitted the code from the server, from the browser, sorry, it got put inside a Docker container, which created the isolation. I wanted Docker not so much for all the things that seem to be common, the service kind of stuff. I wanted it for the isolation. That was the main reason was the security. Okay.
You are aware that it's not very secure, the Docker isolation?
Say again?
It's not very secure, Docker isolation. It's enough.
Exactly right. It's good enough. Okay, it's good enough. Yeah. It's like espionage. It's like espionage and counter-espionage, right? Okay. It's how much time and effort you want to put based on how much threat have you got, right? Now, there's just a quick story here about this. When I did this, in fact, a little bit before I did this, but it was at this time in particular, I realized that there was a flaw because supposing you'd written some code and some tests and you submitted it and there was a bug in your code and the bug manifested itself by an infinite loop. Okay? I'm running the process, waiting for the output so I can regex it to find out whether it's red or green. Never finishes. Okay? So I've had to add some stuff to say, okay, you've got 10 seconds max. Yeah, we run the code, the tests inside the container, and if it doesn't finish in 10 seconds, we just assume that there's an infinite loop and we just kill it. Okay? So if you want to, you can try that, and if you try that, what you'll find is there's actually a third color. Sorry, a fourth color. Fourth color. Red, amber, green, and there's also a gray with a little icon of a clock. Yeah? And that says, sorry, I couldn't give you an answer in 10 seconds, so I just killed it. Okay? But I wasn't anticipating that. That's how it worked next. And just recently, I've done a fair bit of work to put the actual server in a Docker container as well. And again, you just saw me do a demo of that. And the main reason, there's a number of reasons for that, but the main reason was so that if you want to run your own server, it's just much, much, much easier. It's so much easier than it was before when you had to, do a git clone of the repository and issue the magic incantations, and a lot of the time it didn't work, and it was just a nightmare to maintain. Okay? So, any questions from that part? Yeah.
You mentioned you have a Docker container for each language, and you fire it every time someone commits this code.
Every time they hit a test, correct.
Right, and you inject the code from the Git repository to that container.
Correct. Correct. Yeah. We might see the actual code that does that if you like. Okay. Whoops. So I've got a list of things that might be interesting. Does anyone have any particular thing they want to see? I've got an order, but we don't have to do it in this order. We could. For what? The main server? Yeah, okay. Okay, let's have a quick look at those two. So I've got the source code here on my local machine. That's the tests, library, model. Okay, so the main folder is app, and under there we've got languages. Yeah, and the idea loosely is that there's a top-level folder for each language, and if we drill into one of those, which one was it you said? Nothing special. Okay, well let's pick, I don't know, Java. So underneath Java, there's a folder called Docker Context, and that's the one for just the language. The idea is that's the one for the language, and then you build the one for the test framework on top of that for each particular test framework. Okay, so let's have a quick look at that. We can see the Docker file for this one was someone called Luca, and they did the relevant, the correct incantations using the Docker syntax to, create the layered file system, and that gives you Java. Lovely jubbly. I don't know what all this means at all. I just know that if I select Java and I do the stuff, it works and I get reds and greens. Okay. That's the Docker file. To actually make the image, the base image from that, there's just a little tiny shell script so that we can name the container. So that's the base container for the language without the test framework. So then the idea is that there's a subcontainer, a subfolder, I should say, for each test framework that's built on top of that, right? So we did I pick JUnit? I think it was JUnit, wasn't it? Yeah. So that, again, follows the same model. Yeah, here's the Docker context container for JUnit. And in that, again, there's a Docker file. Yeah, and in this one, it's very easy. Some of them are a lot more complicated than this. It simply has to make sure that the JUnit jar file is inside the new image. Oh, it also has to set the class path environment variable. That's interesting. And there's the jar file. Again, if you know the way Docker works, any files that you copy have to be in the context, which is tarred to the server running, the machine running the Docker daemon so that it can actually do the work. So that gives us the image. Yeah, the image, which is Java, in this case, Java plus JUnit, okay? And the only other thing you have to do is set up your initial set of files. So there's another file in the same folder that you can see called a manifest JSON file. And the main thing about that is it sets up the initial source files. Yeah, so for Java, there's one source file for the code and one source file for the test. Again, it's just a bog standard way of starting. Yeah, we can have a quick look at that. Again, that has to be here because that's all becoming part of the image for the web server. So the tests, hello, the tests are here. And again, you might guess, but all of the initial starting files, regardless of what language and test framework you use, follow the same test. There's a test called answer, and it's expecting an answer 42, but it actually returns 6 times 9. That turns out to be quite a useful idea to standardize that, because I can run all kinds of automated tests. Yeah, I can, with an automated setup, an automated test, I can literally get it to run code inside the Docker container, and then I can simulate changing the code on the browser by doing a regex and changing the 6 times 9 to a 6 times 7. And I can, again, simulate that coming back into the browser and doing another test and making sure I get a green back from that, okay? Turns out sometimes it's not as easy as that, because some languages have infix notation, right? You can't just do a 6 times 9, but you can always do enough to change it as if you were typing it to make the change, to simulate the change, to make sure the reds and the greens at least work for the most obvious things, okay? And the other file you always see in the manifest, you have to have this in the manifest, is a file called cyberdojo.sh, and that's simply because it's the known name that the web server kicks off once they've been copied into the container. So what does it look like for Java JUnit? It looks like this, okay? Again, some magic incantations. The idea is you really never have to worry about that. If you rename some files, that should work, yeah? If you rename some files and that doesn't work in any language, then this isn't doing its job because that's part of the design, okay? What was the other thing you said? Oh yeah, the server. So the server lives here. So the Docker file for the server is more complicated. It's based on Alpine Linux, but I had to put a layer on top of Alpine Linux for the user. Okay? When you run Docker, if you read the documentation, it says you have basically the user that's starting at the Docker server has to have root privileges. And they don't actually give it root privileges. They kind of indirectly do it, but it amounts to the same thing by making it a member of a group, and the group has root privileges. Okay? Well, I don't do that. Again, as part of the security kind of thing that Mark was talking about. I have a user called CyberDojo that I want to be universally available. Okay, we'll see that in a minute. Some other interesting things here. What's going on here? Yes, the very first thing we have to do. Again, if you know the way Unix works, the process with PID1 is really special, okay? And when you start up a Docker container and you run whatever it is you're running inside that container, that process might spawn other processes, and those processes have their PIDs, but the first process that you start has PID 1. And one of the things that PID 1 is responsible for in a sort of normal Unix environment is reaping zombies, a zombie process, yeah? But that doesn't happen in Alpine Linux. That's one of the things you pay the price for in terms of having a very, very small image size, okay? So someone created a little tool called Teeny, which you can add in, which I've done, and that reinstates the reaping responsibility of process 1, okay? Otherwise, you could have problems with a long-lived server. Obviously, I'm not worried about this for the images for the language because I know they're going to run a maximum 10 seconds anyway. After that, they're killed, okay? But the web server is obviously designed to be up for quite a while. Next, we have a whole bunch of comments for this bit here. I'm not going to go into that in detail, except to say this is a way of putting the Docker client inside the binary, the image for the server itself. So in this situation, we've got, as you just saw, we've got the Docker clients installed on the host. That was the very first thing we did with install Docker, okay? And we've also got the Docker client installed inside the web image, yeah? There is a reason for that, and the reason is, as it says in the documentation, otherwise you get variation on different base languages, operating systems, okay? So as you can see here, OS X Yosemite has this, when you install Docker on the OS X, that's one of the magic incantations that makes it work, okay? Docker binary lives in a certain location. And wonderfully, if you install Docker on a different operating system, such as Ubuntu, the Docker binary is in a different location, yeah? And there's more as well. I've just commented 2 of these, but there's sufficient differences that that difference would start to propagate and propagate and propagate into all. I'd have to start supporting all the different combinations of how the actual magic incantation is to get the server up, depending on what particular operating system you're on, okay? So I just create a level of abstraction. It's a standard technique by putting the Docker binary inside the client, and of course that avoids the problem because I know what operating system the web server image is because I built it, right? It does obviously create another issue though. There's always something that pops out when you do these designs. I'm now dependent on the version number. The version that you install on the host has to be the same as the version that you install inside the web image, which is exactly what Neil knows about. Yeah, we had some fun. Yeah. So that's that bit there. So here's the bit about not doing it as root. Basically, I do sudos, okay? So I'm having to remember what I did here. Okay, well, the first thing is I want to add a user, not a group, a user, and the name of the user I want to add is the one that's getting sudo privileges for Docker. So what's that? That is Docker runner, okay? So again, I've tried to try and do best practice for this. It's not even the case that CyberDojo, which isn't root, nevertheless has root privileges to run Docker all the time. No, CyberDojo is able to sudo to Docker runner, okay? And Docker runner is the runner that has privileges, root privileges, so that it can run the Docker image. And the point about that is, when I actually want to do something in Docker from inside the image, the web image, at that point I can sudo, I'm already the CyberDojo user, right? I can sudo as Docker runner just for that one incantation, okay? And the window of opportunity at which point we're doing stuff, rooty stuff, is at most just that 10 seconds, okay? So it gets a bit complicated, but you have to fiddle around with sudo. Again, what's this line here? As it says in the comment, one of the things you lose in Alpine Linux is sudo. There's no sudo in Alpine Linux, so you have to install that so that you can do sudo, okay? And then we have to install Ruby. It's a Ruby on Rails server, remember? You'd have to have Ruby on Rails if you're on your machine. You've got to have it inside the server. So So again, that's just pretty straightforward. And the last thing we have to do is copy the source. Yeah? The actual source, the Git repository, the CyberDojo itself, which is the Rails app, okay, plus all the language stuff, et cetera, you saw. A copy of that has to go inside the container, okay? There's a few other bits and bobs, but that's pretty much it. Anything else anyone particularly wants to look at? Otherwise, I'll just go through my list. Where do the carters come from? Okay. As you saw at the front, one of the first things you have to do when you're setting up the dojo is select your language and select your exercise. You saw what happens for the languages. If you select a language, basically that enables the server to know which manifest JSON file we're talking about. And that, in turn, gives it two vital pieces of information. The first one is the name of the image, the Docker image that stuff is going to have to run in. And the second thing is the source files that are starting source files based in the visible files. Okay? And the other thing is the instructions file, which is just a text file, and that comes from the selection of the exercise. But essentially, all that now happens is those two sets of files get unioned together, and they get put into a particular folder on the more or less the hard drive, right, based on the ID. You saw that there was an ID generated. It's actually a 10-digit ID, it's a hex ID, but statistically 6 is enough for uniqueness for enough years to come. So you only have to type 6 in, and it does the completion on the server for you, okay? So with the ID and the animal is also part of the location, the unique location on the file system, okay? You then have all the information you need. You've got the ID and the animal that tells you the location on the file system, and you know the files that they're starting with, so you just dump the files into that location, and then we're off and ready to go, because when they hit test, those are always the files that get dumped, copied into the container, okay? So the carter is essentially the ID, the hex ID, okay? So let's, we can actually see that, I'm thinking, because we've still got the server running here. Let's just check everything's okay. Yeah. So if I shell into the server, there's a magic incantation you can do in Docker to shell, that's handy, to shell into the server. So now inside the web server, and so it should be here. So there's the folders, and there's a folder called carters. And if you go into that, you see, and do an ls, you can see there's actually only one first level folder, and if we cd into that, there's another one, okay, and the sizes are 2 and 8. 2 and 8 make 10. That's basically concatenated, that forms the 10 hex digit. And remembering it starts with 31, and then we go back to the actual demo we were doing. Yeah, and look at the bottom. You can see, can everyone see that at the bottom okay? Yeah, that's the ID. Okay, so it does this on the fly. Now, it's not actually on the hard disk. It used to be on the hard disk, but again, as part of the move towards putting the server inside a container, all the carter stuff is now held in what's called a data container. A data container, okay? It turns out for a good reason, there are good reasons for doing that. If you have the web image effectively its own machine, and somehow it has to access the files on the host that hold the carters, like we just saw, okay? Or we saw some of it. Let me finish that first of all. So if we cd into here, yeah, we can see there's a manifest to remember the information about what the language was, what the exercise was, okay? Not going to bother with that, but there's one folder per animal. We only had one, which is the B, and if we go into that, we can see a few things. Again, I'm not particularly going to go into it unless anyone wants me to, but what we crucially have is the sandbox. And in the sandbox, we can see, as I said, the union of the files that were selected based on the language and the exercise that you picked. So those are the files that get slurped up and copied into the container when you hit the test button, okay? They get 10 seconds to run, assuming they finish. We regex the output. The output goes back to the browser, but of course, something else has to happen. Everything that's in that, inside the files that are inside the container that we span out for 10 minutes get tarred back to the sandbox. Yeah, so we're creating the illusion of persistence here, even though it's going in and out of particular places, okay? And I've lost my thread. What was I doing before I went back to that?
Well, you have to put the file in a document.
Yes, thank you. So if you had the files on the hard disk, on the host, and you had an image, the web image for the server, you potentially get problems such as the users on the host and their rights are different to the users and their rights inside the image for the web server, okay? So you can get around that problem, but that, for example, was one of the problems that I used to have to battle with when everything was just done before it was inside the server was inside a Docker container. So now, through a data container, we can make sure that it's as though the files were inside the web server themselves, except they're not quite. There's a way that you can join different images together effectively, okay? You can create a union of the images, okay? It's, again, one way of making less hassle for me. I just want to get less hassle for me. Any others? Yeah?
Try and get the stack right. So we've got the Docker, then we have the Alpine, which sits in the lab, then to spin up, then we have something for the server, maybe Ruby from Rails, and then the server code. That's roughly the stack that we're looking at for the server piece.
Yes.
And then for when compiling or testing, that's spinning off something, a completely separate Docker instance. There's a 10-second lived instance.
Correct. It's called Docker in Docker. If you're looking at it in the terminology, it's called Docker in Docker. It's a little bit of a misnomer because, at least certainly when I was learning about this, and I heard the phrase Docker in Docker, I was thinking like in the strong sense of like a tree, okay? But it's not like that, okay? It's much more of a sibling relationship, okay?
It reaches out to like another Docker perhaps in reality, runs it in there, but there's this special relationship between them.
Remember, there's only actually one machine. There's the host. Yeah? So the processes are all actually running on the host. But because of the way Docker works, one of the technologies in Docker is a namespacing technology. So you can get the illusion of an isolation, which is why if you're inside the, for example, let's try that. If you're inside, which we are, and we do a PS here, of course it's a different PS. Is it just AX? There we can see. So like we said, Docker PID 1, that's the special one that's now got the TNI installed. And that now instantiates the Rails server so that the root process has the reaping responsibility for the zombies, okay? And the other two are just, one because I've shelled in, and number two because I just did a PS, okay? Yeah. But if we come out and do a PS here, different, okay? Completely different. There's only actually one machine, right? Yeah. I love Docker. It's just so great. Okay. How are we doing for time? How much time have we got?
5 past 5, so 25.
25 minutes. Excellent. Let's have a look at a few sort of codey things. Yes, let's have a look at that. I have quite a strong, I tried to work to a strong domain model. So the domain model classes in Ruby are here. So you can see, for example, there's one called languages. So that represents the collection of all languages. Yeah, and there's one for an individual language, et cetera, okay? Whoops, let's get rid of all these ones I don't need for a minute. And how do I do dependency injection? Because I've tried to be, I've used it as a playground, really. If I wanted to try something out, I just tried it out, okay? And one of the things I don't like about dependency injection is, well, frankly, the injection, right? It kind of seems slightly the wrong way around to me. I have this idea that if Roger's an object and I need to set him up, okay, then I know what he needs, right? I look at his constructor and he says, he's got these two parameters that have to be injected. I say, okay, I know what they are, and then I give them in, okay? Yeah, well, doesn't he know what he needs, okay, in terms of at least the name of the thing, potentially, okay? It's not always the case, but I'd like the benefits we get from dependency injection without necessarily having to put all of the sort of dependency injection that's happening coming back and back and back and back to the root of the system. That's what it feels like to me as a knot of the system, okay? So I do it slightly differently, which I think is slightly controversial. I didn't value people's opinions. I just did it because I tried it, and as always, it has pluses and minuses. But if we pick, for example, the object that represents the individual avatar, like the bee, right? This is the one that has the test. So when you hit the submission on the server, the browser, I should say, your files get sent to the browser, and there's a little bit of extra code so that it knows what's changed. It knows if a file is actually a new file, a changed file, or a deleted file, okay? And it does its stuff, and that calls another bit of code. And if you look through this file here, you'll see that runner is not here. There is nothing in here called runner, because that's an external dependency for this particular class, okay? But it's not injected either. So how does it work? The answer is I follow the bounded context model very strongly. And every object knows who its parent object is. Yeah? In terms of, there's actually a link from each object to its parent object for all of the objects that represent the domain, you know, such as the languages, the exercises, the katas, the animals, etc. Okay? And there's, again, an object, not a class, an object that represents the whole dojo, the whole application. Okay? And so when in Ruby, a piece of code tries to execute and it isn't there, right? What happens is something special. Because, again, if you know Ruby, it's a very dynamic language, and you can tap into the method missing, which is the method that's called when you call a method and the method is missing, right? So this is the line that's doing the magic. There's a module called external parent chainer. Let's have a look at that. In the library, because it's not just used in the domain. It's very simple. As I said, it's called method missing. We mix that in, and all that happens is it says, okay, I'm just going to assume you've got a link to your parent, and I'm going to keep going back to the parent, 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 and I know when I stop having a parent object, I'm in the root dojo object. And all the actual external dependencies are held in the root dojo object, and then you just get access to them, okay? Once we've got the root object, we assume that has the thing, which, if you remember, was runner. Back up here, okay? If we look at the test, it was runner. So the request to do a run on the runner has gone all the way back up to the dojo object, which is, again, part of the domain. And in the dojo object, we've got the runner, okay? What is the runner? The runner is an object that's instantiated using reflection, okay? Because there's an environment variable that names the class that has to be the class that's instantiated to be the runner, yeah? And on the server that you saw me spin up, there's one particular kind of runner, but on the main server, for example, this one, it turns out that's got a different runner, because that one has multiple nodes behind it. It's actually 2 at the moment. Okay, 2 is easily enough to cope with the demand based on the amount of people doing dojos on CyberDojo. Okay, so it has to actually do a very crude form of sharding. Okay, so you have that opportunity to sort of plug something in, but you do it without having to touch any of the code once it's set up. You just have to name the environment variable. So just to finish that story, let's just see how that works in a little bit of detail. Well, I guess let's look at it. What is the external object? How does that work? Well, that's this call down here, okay? What's the name of the caller? Well, the name of the caller is runner, okay? And then it just grabs the environment variable and says, what's the runner class? Yeah, which is the name of the environment variable, the name of the runner class, which we'll see in a minute. And then it uses the reflection library in Ruby to instantiate an instance of that class, okay? And the or equals is just a way of making sure you only do that once. It's just an optimization, which I don't actually need because nothing is held in terms of state, okay? So if we look at how the actual server starts up, which is actually from Docker Compose, okay, we can see that it is set from there. This is the magic incantation in Docker Compose to say, pass the environment variable value for this name, CyberDojo runner class, into the web image. Yeah, into the web container, I should say. When you're spinning up the web container from the image, what environment variables do you want set in that when it starts, okay? Well, what is the value of that? The value of that set in the script file that you saw me running. This is just the CyberDojo script file. CyberDojo up, you saw me do that, okay? So at the bottom of here, it just, again, sets up the correct environment variables for this particular server, which is, again, there are subtle variations. The sudoing is different as well, depending on how you're doing stuff, okay? So it's, as I said, it has pluses and minuses. This idea of just, oh, it doesn't work here, try it one level up. Or it doesn't work, try it one level up. It doesn't work, try it one level up. The very, very dubious thing about this, of course, is the code is much harder to read unless you know that's how it was working, right? And if you get a mistake because you typed something wrong, you get a very particular diagnostic, and you have to learn to recognize that diagnostic. Otherwise, you're just going to waste a lot of time, okay? But the benefit, I feel, just outweighs that tremendously. Refactoring in this code base is such a joy. It's so nice. I can pretty much move anything I like anywhere else, and it wasn't coupled to that actually being part of its dependency context in the first place, so I can just put it anywhere. It always just goes back up the root parent tree to the Dojo object if what I'm actually trying to access is an external. Yeah? And that works not just for the domain objects like avatar, it works for every object that represents an external itself, okay? So if we look at, for example, one of the external objects mentioned was runner, okay? But another one is the exercises object to represent the exercises folder, which is part of the thing you select at the beginning, okay? So if we look at that, okay, we can see that this object that represents an external uses another external. It's gaining access to the disk, right? It all just works. Everything can see everything else when it likes, which again, you could go too far with that. Arguably, one of the reasons I find this nice to work with is because I got quite a lot of tests with it, okay? It would be kind of ironic if I was pushing testing with CyberDojo and there wasn't very much testing, yeah? So I guess I should show you that. Let's have a quick look at that. If we come out, we're back on the host. We're back on the host. And if we go back into the file that had my crib, we can go back into the server. So we're back in the server container now. And if we go into test here, we can see all the test files, because they're inside the container as well. They're inside the image as well. Let's just pick one here. What have we got? We've got the models that we were just looking at. So there's a whole bunch of tests here, and I can just run them. Let's pick the avatar test that we were looking at. And they're running inside the container, which again I really like, because it's kind of a given that when you're running tests, what you want to run the tests on is something that's as close to the actual code as it runs when it's really running, okay? Any gap between what you're testing and what actually happens in reality is a gap where the bugs can creep in. So you don't really want to run these tests outside of the container, and it turns out you can't in here, because on the host I haven't even installed Ruby, right? Yeah? You could do that if you wanted to. If you were doing a local development, you can run a local server without having to spin up the web image at all. Again, that's something perhaps worth saying. Again, I can't do that because I'm on my old MacBook. Okay, never mind. But because ultimately the source, which we can see here, did I put the source in? Yes, I did. Excellent. So here's the source as it's pulled from a Git repo. Yeah? That's the source. It's a Rails app source. You can run it inside a web image container. You can run it on the host. It's the same stuff, right? Okay. So that's typically what I tend to do because it's a faster feedback loop on my local machine. Okay.
In your deployment, do you strip any of that out or just ship the tests? Do they all go with it?
I ship the tests with it.
Okay, so literally it's identical.
Absolutely. Why make it different? Yeah. I'm not getting paid for any of this stuff, not directly. So I'm, as I said, quite aggressive about trying to reduce the bureaucracy. What do people think about that? You like it? Some people don't like it at all. It's quite a bit like Tolkien. People either hate it or love it.
What's the reason that they don't? What do they quote them for not liking it? Is it the IDE thing? Is it because it's too basic? Or?
It's just not. It's not readable enough. Yeah. It's not a static thing. It's interesting, isn't it? Now I think about it as I'm up here talking. I don't mind that at all, but I put much more reliance on the dynamic nature of stuff. Okay. I just recognize that. Okay. I've got my tests and I've got my code, and they co-evolve. And if I'm happy working on that code base, that's what matters, okay? When I was younger, I used to have all these worries about, oh, that's not good in theory. And now I kind of say, well, fuck theory, what's happening in practice, okay? You have to balance the two, but I would say, as I've got older, the balance in terms of when I do design has shifted notably in certain places, okay? One of the ones that shifted, for example, is in terms of testing. When I was younger, I definitely, when I was a paid developer, you know, I would over-encapsulate at the expense of testing, for example. And now I'm much older, I've pushed it much further along the spectrum to the other side, and I'm much happier to sort of open up the encapsulation a little bit if it means I can test things better, yeah? Okay. Don't worry about that one. Yeah, one of the things the testing has been really, really good at is, let's go back in again. Oops. Is helping reveal the coupling. So the thing I've got written down here in particular is the caching. Some of the stuff was at certain times quite slow, and I had to put some caching in to make things faster. So if we look at the languages folder, for example, we can see that there's a cache. There it is. That's not part of the image. Okay, that's something that's dynamically created in the web server container as the container's running when you start it up for the first time. Again, that didn't used to be the case. It caused me all kinds of hassle in terms of admin and bureaucracy and tests failing. That was the big one, tests failing. The caching really hurt me when I wanted to write good tests. So I've stripped out a bunch of the caches, and more than that, I've moved the caches. What I was finding was that I'd have a change happening here, and then a cache would be happening somewhere else. I put the caches together, yeah, and it was a mistake. Now I put each cache next to the thing that it's caching. Yeah, so you can see this is the language cache for the languages stuff, and therefore it's in the languages folder, and it's just much better. It's obviously so much better. But the testing really helped me there, knowing where things, it felt like a shoe pinching, you know, there was something wrong. Something else that was interesting, if we go back to the tests a minute, where were we? We were in the app models, weren't we? Oh, we did that, yeah. And we ran that one. Did you notice when that ran, you can see it again now, that it's a little bit of outputs coming through. The tests all pass, and we'll see that there, okay, but we're getting some kind of output. That doesn't happen when you run the tests locally on a local machine. But it does happen when you're doing the same tests inside the web container. Haven't had time to track that down yet. I've been fishing instead, okay? And there's another one as well. There's a couple that do that. Let's run them all. Let's run all the unit tests from here. Again, this is the same one. I'm not quite sure what that is doing, but the tests all pass, so I'm not particularly worried. I'll figure it out later. Need to scroll past this. Oh, there's a failure. Oh, yeah. This is a new language that someone submitted last week. And one of the tests I have for all languages, except this one's not caught up yet, is I keep a record of some of the output that you get when you have a red test, and some of the output you have when you have a green test, and some of the output that you have when you have an amber test, and I make sure that what I had as red in the past is still red, and what I had as green in the past is still green, and what I had as amber in the past is still amber, so that when I'm having to modify a regex, for example, when a test framework upgrades, it's not at all uncommon when a test framework upgrades that they tweak the output Okay, and then what has to happen is I have to rewrite the regexes so that they work not just for the previous one, but for the current one as well. Okay, and that one hasn't quite caught up yet. Okay, but they all run, except if we go through, there's an S. There's one that is a total failure, nothing to do with new stuff. I don't know why that one's failing. I've just marked it as a skip for now. S means skipped. Okay, so there's a few things that aren't exactly the way they were. And that's just part of the migration of moving the code inside the image rather than running locally. I do coverage analysis, just very crude. And mostly what it's useful is for telling me when there's something that's missed. So that 99.23 is exactly because of what we just saw. That I never heard of sea green, but anyway, that test framework doesn't have those red, amber, green tests yet. Okay. Yeah. Okay. Oops. Yeah, that's a nice one. So back in the tests, where are they? Here we are. Let's do the same one. App models, avatar test. You noticed, you may have not have noticed, but when I ran those, I just typed the name of the file. And the way that works, I've set it up to work, is using shebang. Yeah, so there's a shebang at the top of each test file that says, which shell script do you want to actually run this test file on, okay? So that's the test wrapper shell script in the parent directory of all the tests. These are just the unit tests. And if we look at that one there, we can see that's the wrong file. No, it's not. It's the right file. Okay. There's a few things that are happening. Not sure I've got time to talk about this. Maybe I just briefly talk about it. Each test has a name, which is just a string, because you can do that in Ruby. Okay. But it also has a hex ID, because what I find sometimes is I want to run just one test. Yeah. And I just wanted a quick way of doing that, so I hacked a bit of code together so that I can, as you saw here, just do a run in the right in the right folder and give the ID, and it'll just magically find the right one and just run just that one, regardless of what its name is, okay? This is just collecting arguments. And then here's the interesting stuff, because you notice what this is called. This is test wrapper, yeah? And it's literally wrapping the test call. There's basically three sections. The first thing we do is we make sure we know what the current Git user is. Then we run the tests, and afterwards we say, okay, what's the Git user now? Because if you think about this carefully, you'll realize that some of the tests are actually simulating test button hits, right? Which have files being copied from the animal's location into a sandbox, and then coming back again, and then there's a git commit and a git tag, right? And what was happening, it's not so much of an issue now, but again, if you're doing development on a local machine, you've got the source right here, yeah? And you've got the tests one level up in a directory called tests, and then you're running some of the tests here. And some of those tests are issuing git commands. Now, what happens if you make a mistake in the tests and there's a fault with the git? What does git do, for example, if you try to do a git command in a folder that doesn't have a git repository? Does anyone know, except Byron? It goes up in the tree. Is it going to find a git repository as it goes back up the tree? Of course it is. It's going to find the repository for the whole project, right? Because I've got git as my repository for the app itself, okay? And what was happening was I was running the tests and they'd fail, and not only would they fail, they'd actually have come back and caused a side effect on the actual repository. Yeah? So if you look back at the history of CyberDojo commits on the GitHub repository, you'll find that there's some in there that aren't from any human being. Yeah? They're from the cheetah or something like that. Yeah? Because things just went wrong. Okay? So there's a meta test, kind of a wrapper, literally a test wrapper, hence the name. Stuff happening before, then we run the test, stuff happening afterwards, and we can get some level of confidence that things are the same as they were before. Okay? I know Kevlin likes that pattern a lot. It's the execute around pattern. Yeah? So I use that. And then a big klaxon warning going, if they're not the same as they were before and after, okay? Yeah, talked about that. Talked about that. That's was a quick look. That's on my list. So we're on the host. So if I do a Docker images now, we can see the images, Docker images for the web, the server itself, the Nginx doing the caching, okay? The charters, which is the data container, holding the 10-digit hex IDs for each exercise practice session that people do, which gets bigger and bigger and bigger over time. Okay, at the moment it's nothing because I just literally created this at the beginning of the talk. But if we look at the others, we'll see that these are the image files for the languages. Okay, so GCC assert, if you remember, was the one I said that's based on Alpine Linux, 94 meg. Yeah. And the biggest one we've got here is G++ assert, gig. And there are some that are almost 2 gigs. Okay? It doesn't actually make a difference in terms of how fast it takes to spin up the container based on that image. It's remarkable, okay? But it does make a difference when you have to download those images to run your own server. So again, one of the things that's on my list is to pare those down and pare those down and pare those down so that when you're at least starting up, it's going to be a little bit more pleasant and it'll start up much faster, okay?
Can you show us the process of adding a new language? Is that easy to do, or is it pleasant trial?
Well, I can show you where to go, because people ask me that all the time, and at the beginning I just wrote an email, but I collected bits and bobs from the emails together. And if you go to the home page, you'll see there's always a Learn More here. So if you go to Learn More, there's a whole bunch of stuff. And one of the things is, how do I add a new language to CyberDojo? So if you click on that one, then there's all kinds of details, which basically, some of it is just repeating what you saw me do, right? There's the language initial level, and you have to make a container for that. Or actually, you don't have to make an image for that. You might be able to reuse one that's already there. That's totally fine, okay? And then you have to, I'd like you to follow the same model that your test framework is based on the image for the language. You can have lots of test frameworks based on that image, okay? But these are all the instructions of how to do that. And I know those are not bad, because the guy who did the sea green actually stumbled a couple of times, because these instructions had to change as I upgraded the mechanism to put everything inside the web server. And he stumbled and emailed me. He said, John, I'm struggling here. How do I get this up? And we had a bit of backwards and forwards, and I said, no, and he was up and running. And then I went back to visit this to find out why was he struggling. And there were some things that were just out of date because it was different. It was different, okay? But everything in here should be okay. There's one thing I've had to comment out. There is actually a test that you can run, which does a whole bunch of tests to say, okay, does that actually look right? Does that look right? Does that look right? Does that look right? Okay. But that, again, that doesn't work, again, as a side effect of moving things inside the container. But that's high on my to-do list. It's not hard, but you do have to start to get some Docker foo. Yeah. You can ask Byron. How hard would you say it is? Yeah, it's not too bad now. It's getting better. Oh, that's a good idea. Yeah, I can do that. Then it'll just work. Yeah, I must do that. Yeah, lovely. Thanks. Good tip.
How do you actually deploy the server to Google? So when you make a change,
Right.
how do you actually deploy it?
It's a good question. If we go back to our host, yep, so I'm shelled into whatever this machine is now, then you can see I did the installation, but I also copied the source repository, which is now here. We're in a Git repository here, right? Yep. And in here, if we go into Docker, web, sorry, then you can see there's a script file there, buildimage.sh. And if you've been fiddling around in this repository here, yeah, making changes, then obviously those changes are going to have no effect on the server that's running. So what you'd have to do then, after having made the changes, possibly run some tests, got some confidence things were pretty much what you liked, and you wanted to actually, you know, deploy that, you'd go into the app docker web folder, you'd run the script to build the new web image, and then you'd have to do CyberDojo down, because the previous image is the one for the current container, and then you'd do CyberDojo up, okay, and that will bring you a new container from the new image, and then you'd be able to actually play with your modifications, okay? I haven't documented that yet, which is very, very even higher on my list of to-dos. I haven't done that because I went fishing instead.
I've got a 3-line script that does it.
It's all you need, absolutely. That's all you need, yeah. I just haven't done it. How are we doing for time now? Yeah, we there?
Yep.
Any other questions? One more? Yeah.
Do you keep track of usage of the CyberDojo site? The other you know when people
Yeah.
how many people have used it?
I don't know how many people have used it in this, because again, one of the ways I encourage it is that it's a pair per animal. I know how many animals have used it. I know how many sessions with a unique 10-digit ID have been used. But I have to qualify that because sometimes people will just go in and they'll hit the test button once and they'll think, and then they'll go away again, okay? But the number of actual practice sessions on the server is over 40,000 now, okay? Some of them are obviously going to be quite small, but quite a lot of them are quite big. A lot of them are the ones I do when I'm visiting and consulting places, for example, okay? And I haven't lost one yet in 6 years. There's 6 years worth of Carters up there. And there's some exciting stuff to come, so watch this space, okay? Any others? One more maybe? Yeah, Phil?
What was the first few languages and frameworks you learned?
C and assert. Simplest thing to think of. Yeah. Well, I'll do what Olve does. My friend Olve is genius. Whenever he's doing a talk and we get to the end of the official time, he says, there we go. That's the end of the official time. If you want to go now, you can go. But if you want to stay and ask a question, you can stay and ask a question, okay? So we'll just have a moment where you can leave if you want to leave. Thanks a lot.